everyone, welcome to another round of video on network concepts. In this video I'm going to talk about directed networks and weights. So these are the two new terminologies that I'm going to add in existence to the previous video where I talked about what a network is, what is it made up of, what a network diagram looks like, what are the different parts of the network, and what a path, a walk, a cycle, and a degree of the vertex can be calculated. So please check out the other video on these basic terminologies. Now let's focus on the directed network. So a directed network is nothing but a network consisting of arrows on edges. So basically it tells the direction where the path is leading. So like for example, this arrow is pointing this way, so it's coming towards A. Now this one is going to B. So it's basically telling where are we going from, where are we starting and where are we ending. So like, take a look at this example. How many different paths are there from A to D in this network without completing any cycles? So now remember the definition of a cycle. A cycle is a closed walk, meaning the first and the last vertices must be the same. So the question is without completing any cycles. So there are two. How from A you go all the way to C and then go to D. That's it. If you would have come back to A, that would have been a cycle. But it said without completing any cycle. Now the other one is we have to get to D from A. So let's see, where can we go? So we can go from A to B, then to C, then to D. And that's a walk. All right. So yeah, that's what the directed networks help us to decide. Now let's take a look at the word weights. Some networks have weighted edges. So now in the applications, you will definitely make use of this. So if there is a number on this line right here, this is your edge. So that means that's the weight of the edge. Now, the weight of an edge might be a distance, a cost, a time, or some other measurement appropriate to that particular network. So in this network, we are using money, the cost. This network shows the cost of connecting points to a computer system. The cost to connect A to B is 618. The cost from B to C is 645. If connected directly, or 975 if B is connected first to E and then to C. So again, you have to imagine the direction part of it. So if you're connecting from A to B and then to C, so which one is cheaper? Basically, what's the best cost efficient pathway that you can take? All you have to do is you're going to add the weights. So if you have to go from A to C, you can go from A to E, E to C, or you can go from A to B and then B to C. Now, which one is cheaper? Definitely from A to E to C, because this is only 550. This is 580 compared to adding 618 plus 645. So you will be coming across these kind of applications where you have to add the sum of the weights on the edges and decide which one is the optimal choice for effective cost or effective time completions or the shortest distance, things like that. All right, guys, thanks for watching. Check out the next video. I'm going to talk about other concepts that are involved. So this is my second video on the terminology that you would be required. So thanks for watching again. Hope this was helpful. Have a wonderful day.